The last part of our test review talks about solving trig equations. And so we're really going to look at breaking this up into 3 different parts. All right, so the first part would be a problem where you only have a theta in the equation. So that would be like the top 3. Okay, so for these 3, you're basically solving for your function and then looking at where the angles are that make that a true statement. All right, so for the first one, I would take 5 cosecant theta minus 3 is equal to 2. I would add 3 to both sides. So that's going to give me 5 cosecant theta is equal to 5. And then I'm going to divide both sides by 5. All right, so I get cosecant theta is equal to 1. All right, and so then I need to determine where that happens. All right, more than likely I'm going to need my cosecant graph to answer that question. So I am going to draw my sine graph. And on top of that sine graph, I am going to draw my cosecant graph. Then I can get rid of the sine graph. So this is again where it's important for you to have your graphs down so that you can very quickly draw these graphs and know where your points are going to be. So I need a place where cosecant is equal to 1. That's going to happen right here. And that tick mark underneath that is pi over 2. All right, so my answer to this one is theta is equal to pi over 2. All right, so for the next one, we have 2 sine squared theta minus 1 is equal to 0. Again, we're solving for the sine theta, so I'm going to add 1 to both sides. That's going to give me 2 sine squared theta is equal to 1. I'll then divide both sides by 2. Sine squared theta is equal to 1/2. I'm then going to take the square root of both sides. So I'll have sine is equal to positive or negative. The square root of 1 is just 1. The square root of 2 is going to stay the square root of 2. And then I'm going to rationalize. All right, so rationalizing this would be multiplying top and bottom by square root of 2. So we're looking at places where sine is equal to square root of 2 over 2. And because it's plus or minus, we're looking at all 4 quadrants. Okay, quadrant 1 and 2 would give you the positives, quadrant 3 and 4 would give you the negatives. So I know that this is going to be pi over 4. And then it's going to be every reflection of pi over 4. So if you need to draw the graph, you can. Here's pi over 4 right there. Reflecting into the second quadrant, you're at 3 pi over 4. So I'm just going to write them up here. So pi over 4, 3 pi over 4. Reflecting into the third quadrant, you're at 5 pi over 4. And reflecting into the fourth quadrant, you're at 7 pi over 4. All right, so you have 4 answers to that particular problem because of the squared. All right, and then the last one in that section square root of 3 cotangent plus 1 is equal to 0. All right, so again, we're just going to solve for the function, so we'll be solving for cotangent. So we're going to start by subtracting the 1 from both sides. So that gives me square root of 3 cotangent theta is equal to negative 1. Then divide both sides by the square root of 3. So I have cotangent is equal to negative 1 over the square root of 3. I'm going to rationalize that by multiplying top and bottom by square root of 3. So I'm looking for places where cotangent is equal to negative square root of 3 over 3. Now I know that there are two answers to that because I know that my cotangent is negative in the quadrant 2 and also in quadrant 4. And so I'm asking myself, where is cotangent equal to square root of 3 over 3? And I know that that's happening at pi over 3. So I'm going to draw my pi over 3. That's my memorized value. And then I'm going to reflect that angle into the right quadrants. So I need it to go to quadrant 2. So that's going to be 2 pi over 3 as one solution. And then I'm going to reflect it into quadrant 4. So I'll just kind of bring it down here. And that's going to be 5 pi over 3. And that will be my second answer. All right, so that set of problems, again, remember you just have a theta in the problem. You solve for the function. All right, and those for the most part should be fairly straightforward for you. All right, so the next group is a little more involved because you have something in the parenthesis other than just a theta. So that's going to be these next two. All right, so starting with the first one, remember that we want to start by asking ourselves, where is cosine equal to negative square root of 3 over 2? All right, so I dropped the 2 to begin with inside the parenthesis. We'll put it back later. All right, so what do I know? I know that cosine at pi over 6 is square root of 3 over 2. So there's pi over 6. And I know that cosine is negative in the second and third quadrant. So I'm going to take that angle, that pi over 6, and I'm going to reflect it over into the second quadrant. All right, so that angle is going to be 5 pi over 6. And then I'm going to take that angle and reflect it down into the third quadrant. And that angle will be 7 pi over 6. And so I'm getting my two sort of base angles. Now remember that you have to do rotations on these. So on this, you're going to add 2 pi to each of these angles sort of repeatedly. And adding 2 pi, in this case, because our denominators are 6, is adding 12 pi over 6. Okay, so 5 plus 12 is going to make the next one 17. 17 plus 12 is going to be 29. And I could keep going if I wanted to, but we have said that usually 3 is enough. All right, on the bottom set, we'll do the same thing. We're going to add 12 pi over 6. So 7 plus 12 is 19 pi over 6. Add 12 again, we're going to get 31 pi over 6. And again, you could keep going if you wanted. All right, so now you're going to go back to the original problem. The original problem is cosine 2 theta is equal to negative square root of 3 over 2. And you're going to ask yourself, how can I make 2 theta equal the first value over here. So we're going to solve this thing for theta. So I can multiply both sides of this expression by 1/2, and that will solve for theta, or divide by 2, however you want to look at this. I'm going to multiply by 1/2. All right, so what that gives me is my first true answer to the problem. So that's going to be 5 pi over 12. Okay, and then remember that if you multiplied the first answer by 1/2, you're going to multiply all of the answers by 1/2. So I'm going to come back over here to where I had this list of solutions, and I'm going to multiply each one of these by 1/2. All right, so we have 17 pi over 12 for the next one. We have 29 pi over 12. In the second group, we're going to have 7 pi over 12. We're going to have 19 pi over 12. And 31 pi over 12. Now, you are going to be told, and I didn't type it on the review sheet, but you're going to be told to stay within one rotation between 0 and 2 pi. So remember that all of our answers here have a 12 on the bottom. So that means that if we don't want to go any bigger than 2 pi, and our denominator is 12, we don't want anything bigger than 24 pi over 12. So what that tells me is that this answer is too big and this answer is too big, but the other 4 are okay. All right, so my answers here, final answers, we would have 5 pi over 12, 17 pi over 12, 7 pi over 12, and 19 pi over 12. All right, so you can see, again, that particular type of problem where you've got something other than just a theta is definitely more work than the first set. All right, so we'll go ahead and look at the second problem like that. Make sure we are okay with that. All right, so again, as we get started, we are going to ignore the 1/2 that sits in front of the theta. So we're simply going to look at this problem as if it were tangent theta is equal to the square root of 3. So I need an answer in the first quadrant and the third quadrant. My first quadrant answer is a memorized value, so I know that pi over 3 has a tangent value of square root of 3. All right, let's also take that into the third quadrant and see what we have there. Okay, so I'm going to draw pi over 3. I'm then going to send that same angle down to the third quadrant, just extending the line. All right, so that angle will be 8 pi over 6, which is going to reduce to 4 pi over 3. So that's going to be my other one. Okay, so sorry about that. Let me get rid of that. All right. Okay, so 4 pi over 3, I'm going to leave that. That's not wanting to erase there. We'll just pretend like I did. 4 pi over 3 will be the second answer. Okay, so now let's do our rotations. All right, so remember that we're going to add 2 pi to these things. So adding 2 pi, when we have a denominator of 3, is going to be like adding 6 pi over 3 to these things. All right, so let's do that. So 1 pi over 3, add 6 is going to make 7 pi over 3. Add 6 again, we're going to have 13 pi over 3. All right, on the bottom rotation, 4 plus 6 is 10 pi over 3. 10 plus 6 is 16 pi over 3. And again, we could continue in either of these lines. All right, so now we have our rotations. Let's go back to the original problem and let's look at what we need to do there. So my original problem is tangent theta over 2 equaling square root of 3. So my question is, how do I make theta over 2 equal to one of these answers over here? So we'll start with the first one, the pi over 3. So if I want to solve this equation for theta, then I'm going to need to multiply both sides of this expression by 2. All right, so one of my answers is going to be 2 pi over 3. All right, and then remember that if you do it to the first answer, you're going to do it to all the answers. But also remember that you don't want any answer bigger than 2 pi. So if my denominator is 3, I don't want anything bigger than 6. Okay, so let's keep that in mind as we look at these other answers. All right, so I'm going to multiply this one by 2, this one by 2, this one by 2, times 2, times 2. And I think everything else is going to end up being too big. So the first one, 7 pi over 3 times 2, that would be 14 pi over 3, too big. Even the bottom one, the 4 pi over 3, when we multiply by 2, we're going to get 8 pi over 3, also too big. All right, so this one actually only has, you should only have this one answer at 2 pi over 3. All right, so once that's done, let's go ahead and look at the second set of problems. All right, and I think since I'm having a little bit of technical difficulties here, I'm going to stop and restart on that second set. Okay, so I'll send you one more link for those last 3 problems.